And now in this lecture we find out the maximum area of a rectangle that is inside the triangle. In the drawing we have triangle ABC. Inside this triangle ABC we have this rectangle PQST. And our mission is to find out the maximum area of this rectangle PQST. In addition, we know that side AB of this triangle ABC equals to 10 units in its length, side AC equals to 17 units in its length. This is side BC that is equals to 21 units in its length. I repeat again that our mission is to find out the maximum area of this rectangle PQST. So in the first step, we will do a construction. That is to say, from point A, we will go perpendicular on PQ. Again, from point A, we will go perpendicular on PQ. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We will define the touching point of the perpendicular from point A in PQ. This point is point M. In the next step, we'll extend the perpendicular AM by straight line until it touches side BC. And we define the touching point of the extended perpendicular AM in this side BC. This point is point N. By doing this construction, we can adhere those two angles that are defined as corresponding angles. Again, those two angles are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other. So those two angles are equal to each other according to the rule that corresponding angles between parallel lines are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees. Likewise, those two angles are also defined as corresponding angles, and they are located between the two same parallel lines PQ and BC, and therefore they are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees. In the next step, we define the length of this line segment BT as x. So what is the length of this line segment NC? Although it is very easy to see that NC equals to BC minus BT. Again, NC equals to BC minus BT. Again here, so NC equals to BC minus BT. Here actually we have to define line segment BN as S, as point X. So here, actually, this is line segment BN that we defined as X. Okay, BN equals to X, and therefore NC equals to, again, write it down, line segment BN equals to X. And therefore line segment NC must be equal to BC minus BN. Again, BC minus BN equals to NC. So write it down. BC, actually NC equals to BC minus BN. So NC equals to BC, that is 21 units in its length according to what is given in the question, minus BN. BN equals to X according to our definition. This is line segment BN is equal to X. So in total, NC equals to 21 minus X. NC equals to 21 minus X. In the next step, I'll copy this right triangle, triangle A and B in a new page, and we'll implement on this right triangle A and B the Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is the version for Pythagoras theorem. Side BN equals to X according to our definition. The hypotenuse AB equals to 10 units. And AN is the missing side. So okay, this is the right triangle, triangle A and B that I covered from the original drawing. This triangle, triangle A and B according to the Pythagoras theorem. AB square equals to AN square plus BN square. AB is 10, therefore AB square is 10 squared, it is 100. And this is equals to AN square plus BN square. BN is X, therefore BN square is X squared. And so we found out that according to equation 100 equals to AN square plus X squared. Here we subtract X squared for this equation, equation 1. When you get that AN square equals to 100 minus X squared. In the next step, I copy this right triangle, triangle A and C in a new page, and we implement the Pythagoras theorem on this right triangle A and C. Here by PT is the version for Pythagoras theorem. Side NC equals to 21 minus x units in length, according to what we have already found out. The hypotenuse AC equals to 17 units in its length. So actually, this is the right triangle, triangle A and C that are going from the original drawing. According to the Pythagoras theorem, in this right triangle, triangle A and C, AC squared equals to AN squared plus NC squared. AC is 17, therefore AC squared is 17 squared, that is 289. And it is equals to AN squared. AN is the missing side, so we leave it as it is. Plus NC squared. NC is 21 minus x, therefore NC squared is 21 minus x squared. So according to equation 2, we can find out that 289 equals to AN squared plus 21 minus x squared. Here we subtract 21 minus x squared from this equation, equation 2. And we get that AN squared equals to 289 minus 21 minus x squared. This is according to equation 2. Well, according to equation 1, we already found out that AN squared equals to 100 minus x squared. So we have two different equations for the value of AN squared. Therefore, we get equation 3 that states that AN squared according to equation 1 must be equal to AN squared according to equation 2. AN squared according to equation 1. So equals to 100 minus x squared, and it must be equal to AN squared according to equation 2, that equals to 289 minus 21 minus x squared. So according to equation 3, we found out that 100 minus x squared equals to 289 minus, here we have 21 minus x squared, and 21 minus x squared equals to 21 squared, that is 441 plus x squared minus 2 times 21 times x, that is minus 42x. So according to equation 3, I should found out that hundred minus x squared equals to 289 minus 441 plus x squared minus 42x. So it is 100 equals to 100 minus x squared equals to 289. So here we open the brackets of this expression. After we open the brackets, we have here minus 441. Here we have minus x squared. And here we have minus times minus is plus, so it is minus 42x, that is plus 42x. So according to equation 3, I actually found out that 100 minus x squared equals to 289 minus 441 minus x squared plus 42x. So here we have x squared on both sides of this equation, so we have minus x squared on both sides of this equation 3, so minus x squared will get cancelled. After we cancel minus x squared, in this side of the equation we left only with 100, and it is equals to, here we have 289 minus 441 plus 42x. So here we add 441 to this equation, equation 3. So we get that 100 plus 441 equals to 541. And it is equals to 289 plus 42x. So here we subtract 289 from this equation, equation 3. And get that according to this equation, equation 3, we have 541 plus 289 is 252, and it is equals to 42x. So here we divide this equation, equation 3 by 42, and so we get that x equals to 252 over 42 is 6, so x equals to 6 units in its length. So actually, line segment BN is equal to x is equals to 6 units, and here we have line segment NC is equals to 21 minus x, 21 minus x is 21 minus 6, that is 15. In the next step we return to equation 1. According to equation 1, we should found out that an square equals to 100 minus x squared. And just like now found out that x equals to 6, therefore x squared is 6 squared, that is 36. So in total we have found out that an square equals to 100 minus 36, because x squared is 36. 100 minus 36 is 64, so according to equation 1, an square equals to 64. We take out of this equation and get that an equals to the square root of 64, that is 8. An equals to 8. So this is line segment AN, and it is equal to 8 units in its length, so I write it down. AN equals to 8 units in its length. We know that PQST is a rectangle, and all the angles in a rectangle are right angles. So those two angles are both right angles. This angle equals to 90 degrees, and this angle also equals to 90 degrees. We define the width of this rectangle PQST, that is to say PT is B and we define the length of this rectangle PQST as A. That is to say PQ equals to A according to our definition. And we'll focus on the small quadrilateral PM and T. Inside this small quadrilateral PM and T, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore this fourth missing angle must be equal to 90 degrees in its size. So inside the small quadrilateral PM and T we have 4 right angles, and according to rule 6, any quadrilateral that has 4 right angles must be this rectangle if not a square. So we relate to this small quadrilateral PM and T as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle PMNT, side PT must be equal to the opposite side MN. But PT is B, therefore MN must be also equal to B. So what is the length of line segment AN? From the drawing it is very easy to see that AM equals to AN minus MN. So repeat again, AM equals to AN minus NM. So AM equals to AN, that is 8, minus NM, that is B. So in total, AM equals to 8 minus B. This line segment AM of find AM equals to 8 minus B. Those two angles now defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other. So if this angle is alpha, then this angle must be also equal to alpha because those two angles are equal to each other according to the rule that corresponding angles between parallel lines are equal to each other. Likewise, we have those two angles. They are both defined as corresponding angles, and they are located between the same two parallel lines, that is to say PQ and BC, and therefore they are equal to each other. So if we define this angle as beta, then this angle must be also equal to beta because they are equal to each other. Okay, so in the next step we prove that the big triangle ABC is similar to the small triangle APQ. So I write it down. We prove that the big triangle ABC is similar to the small triangle APQ. So why the big triangle ABC is similar to the small triangle APQ? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to beta, therefore they are equal to each other. And finally, this is angle A, that is a common angle, it belongs to both angles. So can I know that angle A equals to itself, it's a common angle that belongs to both triangles. So she found out that all the three angles in the big triangle ABC are correspondingly equal to all the three angles in the small triangle AQP. Therefore, those two right angles are similar to each other according to angle, similarity rule. So write it down. The big triangle ABC is similar, this is the sign of similar, to the small triangle APQ. According to angle, similarity rule. Whenever you have two similar triangles, then the ratio between their heights must be equal to the ratio between their sides. Repeat again, whenever you have two triangles that are similar to each other, then the ratio between their corresponding heights must be equal to the ratio between their corresponding sides. So, the big triangle ABC is similar to this small triangle APQ, and therefore the height AM in the small triangle APQ over the height AN in the big triangle ABC must be equal to side PQ of the small right triangle APQ over side BC of the big triangle ABC. So this equation 1 is that the ratio between the heights of the two similar triangles must be equal to the ratio between their sides. Okay. So AM equals to 8 minus B over AN equals to 8 and it is equals to PQ equals to A according to our definition over BC equals to 21 units in itself according to what is given in the question. In conclusion, we should have found out that according to equation 1, 8 minus B over 8 equals to A over 21. Here we cross multiply this equation 1. And we get that 8A equals to 21 times 8 minus B. Here we divide this equation 1 by 8. And finally we get that according to equation 1, A equals to 21 over 8 times 8 minus b. Here we'll open the brackets on this side of this equation 1 and get that a equals to 21 times 8 over 8 is 21 minus 21b over 8. In the next step, we multiply this equation 1 by b, and you get that a times b equals to 21b. And here we have minus 21b over 8 times b equals to minus 21b squared over 8. So, what is the meaning of a times b? A is the length. A is the length of this rectangle PQST, and b is the width. The length times the width, the length times the width equals to the area of any rectangle, and therefore I shall find out that the area of rectangle PQST equals to 21b minus 21b squared over 8. So the area AB depends on the independent variable, that is b, the width b. And our mission is to find out the maximum area of this rectangle PQST. So in order to find out the maximum area of this rectangle PQST, we have to find out a times b is the area, so we have to find out the maximum value of this function, a times b. And that is to say for which b is the width, the area that is a times b will be in its maximum value. In order to find out what is the maximum value of a times b, that is the area of this rectangle PQST, we have to differentiate this function area and equate its derivative to 0. In this way, we find out the extreme points of this function area of rectangle PQST. Whenever you have an extreme point, the extreme point could be minimum extreme point or it could be maximum extreme point. In order to verify that we found indeed the maximum extreme point, that is what we are looking for out in this question, we have to find out the maximum area of this rectangle PQST. So in order to verify that we indeed found the maximum extreme point and not the minimum extreme point, I will just draw the graph of this function area of rectangle PQST, and from the graph itself we can easily see if the extreme point that we found is maximum extreme point or minimum extreme point. So in the first step we differentiate this function area. Here we have d is abbreviation for derivative. The derivative of this function area, that is 21b minus 21 over 8 b squared. And we will differentiate it according to the independent variable, that is b. So it is according to the independent variable, that is b. And we have to equate this derivative to 0 in order to find out extreme points of this function area. So what is the derivative of 21b. Actually, we know that the derivative of b is 1, and therefore, in total, the derivative of 21b will be 21 times 1, that is 21. And what is the derivative of minus 21 over 8 times b squared? Actually, you know that the derivative of b squared is 2b, and therefore the value of this expression minus 21 over 8 times b, after we differentiate it, will be equal to minus 21 over 8 times 2b, because the derivative of b squared is 2b, and it is equals to 0. Repeat again, if we found out that the derivative of this function area 21b minus 21b squared over 8, this is the function area of this rectangle PQST, the derivative equals to 21 minus 21 over 8 times 2b, and we have to equate this derivative to 0 in order to find out extreme point or points of the function area, this function area of this rectangle PQST. So in the next step, we take 21 as a common factor out of those two expressions. So 21 is a common factor. What is left from 21 after we took from it 21 is a common factor? What is left is actually 1. And here we have this expression minus 21 over 8 times 2b. What is left from this expression after we took from it 21 is a common factor? What is left is actually minus 2b over 8, and it equals to 0. So here we divide this equation 2 by 21. 21 over 21 is 1, so 21 will get cancelled, and we left only with 1 minus 2b over 8 in this side of the equation. In the other side of the equation, we have 0 over 21 is 0. So conclusion, we found out that 1 minus 2b over 8 equals to 0. Here we'll add to this equation 2b over 8. And again, to this equation 2, 1 equals to 2b over 8. So here we divide both the numerator and the denominator of this expression by 2, and we get that according to this equation 2, 1 equals to 2b over 2 is b, over 8 over 2 is 4. So according to equation 2, we found out that 1 equals to b over 4. Here we multiply this equation 2 by 4, and finally we get that according to equation 2, b equals to 4 units in its length. So we found out that the extreme point of this function area is b equals to 4. So in the next step, we'll draw the graph of this function area in order to find out whether if the extreme point b equals to 4, it is minimum extreme point or maximum extreme point. Actually, I only draw the function area of rectangle PQST. This is the function area of rectangle PQST. In the y-axis we have the area, in the x-axis we have the width B. And it is very easy to see from the graph that when B equals to 4 units in its length, that is the extreme point for a function area, then the area of rectangle PQST is in its maximum value, that is a little bit bigger than 40 square units. So this way actually proves that the extreme point B is equal to 4, it is indeed maximum extreme point and not minimum extreme point. Now the only thing that is left to find is to find what is the maximum area of rectangle PQST when the width B equals to 4. So actually you have to put the value of B, that is 4, inside the function area in order to find out what is the maximum area of this rectangle PQST. This is the area that we are looking for. And the function area of this rectangle PQST, that is to say A times B, that is the area of rectangle PQST, is equals to 21B plus 21 over 8 times B squared. Now we have just to substitute B by 4. And you get that the area, the maximum area of rectangle PQST, that is 8 times B equals to 21 times B. And B is 4 minus 21 over 8 times B squared. B is 4, therefore B squared is 4 squared, that is 16. So the maximum area of rectangle PQST equals to 21 times 4 is 84. And we have here this expression, we have here 16 over 8, that is 2, so in total the value of this expression equals to 2 times minus 21, that is minus 42. So the maximum area of rectangle PQST equals to 84 minus 42, that is 42. So we found out that the maximum area of rectangle PQST is equals to 42 square units. That is actually the answer to the question. Repeat again. The maximum area of this rectangle PQST is 42 square units. And when the area is 42 square units, then the width of this rectangle PQST, the width B equals to 4 units. And what is the length? We find out the length according to equation 1. The length A equals to 21 minus 21 over 8 times B. We just have to substitute B by 4 in this equation, equation 1. And we get that A equals to 21 minus 21 over 8 times B. B is 4. So A equals to 21. Here we divide both the numerator and the denominator of this expression by 4. 4 over 4 is 1, so in the numerator we left only with minus 21. And here we have 8 over 4 is 2. So the length of this rectangle PQST, the length PQ, that is A, the length A equals to 21 and minus 21 over 2 is minus 10.5. The length A is 21 minus 10.5, that is 10.5. So in conclusion, we found out that when the area, the maximum area of this rectangle PQST equals to 42 square units, and when the area equals to 42 square units, the width B is 4, and the length A is 10.5. And again, the width A and the width B course is 4, and the length A is 10.5. The length times the width is the area, so the area is 10.5 times 4 is actually 42 square units. So in the next step, I'll summarize the lecture. In this lecture, we found out the maximum area of this rectangle PQST that is located inside this triangle ABC. We know that side AB of this triangle ABC equals to 10 units in its length, side AC equals to 17 units in its length, and side BC equals to 21 units in its length. Again, our mission is to find out the maximum area of this rectangle PQST that is inside this triangle ABC. So in the first step we did the construction, that is to say from point A we draw perpendicular on PQ. So this angle equals to 90 degrees and this angle also equals to 90 degrees according to our construction. In the next step we actually extended the perpendicular AM by side line until it touches side BC, and we find the touching point of the extended perpendicular AM with side BC. This point is N. Actually, by doing this construction, we find that here two corresponding angles. Those two corresponding angles are located between the parallel lines PQ and BC, and therefore they are equal to each other according to the rule that corresponding angles between parallel lines are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees. Likewise, those two angles are also defined as corresponding angles and are located between the same parallel lines PQ and BC, and therefore they are equal to each other. But this angle equals to 90 degrees according to our construction, therefore this angle must be also equal to 90 degrees. In the next step we defined this line segment BN as X. So what is the value of NC? NC equals to BC minus BN. That is to say, NC equals to BC, that is 21, minus BN, that is X. So in total, NC equals to 21 minus X. Okay. In the next step, I copied this right triangle A and B in a new page, and represented the Pythagoras theorem in this triangle ABN. This is triangle ABN that occurs from the original line. This right triangle A and B equals, according to the Pythagoras theorem, AB squared equals to AN squared plus BN squared. AB is 10, therefore AB squared is 10 squared, it is 100, and it is equals to AN squared. AN is the missing side, so we leave it as it is, plus BN squared. BN is X, therefore BN squared is X squared. So according to equation 1, we found out that 100 equals to AN squared plus X squared. Here we subtract X squared from this equation 1, we found out that AN squared equals to 100 minus X squared. This is according to equation 1. In the next step, I copied this right triangle ANC in the new page and implemented the Pythagoras theorem on this right triangle ANC. So This is right tangent ANC to the point of the original domain. In this right tangent ANC, the produce AC equals to 70 units in itself, and we already found out that AC equals to 21 or 6 units itself. According to the Pythagoras theorem, in this right tangent ANC, AC squared equals to AN squared plus NC squared. Again, AC squared equals to AN squared plus NC squared. So AC is 17, therefore AC squared is 17 squared, that is 489, and it is equal to AN squared. AN is the missing sign, so we leave it as it is, plus NC squared. NC is 21 minus x, therefore NC squared is 21 minus x squared. So here we subtracted 21 minus x squared for this equation, equation 2, and I found out that AN is equals to 289 minus 21 minus x squared. This is according to equation 2, while according to equation 1, we already found out that AN squared equals to 100 minus x squared. So we have two different expressions for the value of AN squared, or two different equations for the value of AN squared. Therefore, we actually created equation 3 that states that AN squared according to equation 1 must be equal to AN squared according to equation 2. AN squared according to equation 1 is 100 minus x squared, and it must be equal to AN squared according to equation 2, that is 289 minus 21 minus x squared. In the next step, we open the brackets of this expression, 21 minus x squared. We found out the 3 that 100 minus x squared equals to 289, and after we open here, we haven't opened the bracket yet, so it is minus 441. Actually, the value of 21 minus x squared equals to 21 squared, that is 441, plus x squared minus 2 times 21 times x is minus 42x. In the next step, we open the brackets of this expression, and we found out that 100 minus x squared equals to 289 minus 441 minus x squared plus 42x. So here we have x squared on both sides of the equation, so x squared will get cancelled. And after we cancel x squared, in this side of the equation we have to leave with 100. On the other side of the equation we have 289 minus 441 plus 42x. So here we added 441 to this equation 3, and when we found out that 100 plus 441 is 541, and it is equal to 289 plus 42x. Here we subtracted 289 for this equation 3, and when we found out that 441 plus 100 is 541 equals to 289 plus 42x. Here we subtracted 289 from this equation 3, and finally found out that 541 plus 289 equals to 252, and it is equal to 42x. Here we divided this equation 3 by 42, and finally found out that x equals to 252 minus 46 is 6. Okay, so x equals to 6 units in length. Here this line segment Bn is equal to x is equal to 6, and here we have nc equals to 21 minus x, that is to say 21 minus 5, that is 15. And the next step actually return to equation 1. According to equation 1, an squared equals to 100 minus x squared. So an squared equals to 100 and x is 6, therefore x squared is 6 squared, that is 36. Therefore, an squared equals to 136, this is 64. An squared equals to 64. Here we took out of this equation and find out that an equals to the square root of 64, that is 8. Okay, so here, side an equals to 8 units instead. Here, I wrote it here. So, in the next step, we define the width of this rectangle PQST, that is to say PT is B, and the length PQ is A. Then we know that PQST is a rectangle, and all the angles inside any rectangle are right angles. Therefore, those two angles must be right angles. So, in the small polygonal PMNT, we have 1, 2, 3 right angles. Therefore, this fourth angle must be also equal to 90 degrees. According to the rule that the sum of the angles in any polygonal is equal to 360 degrees. So inside the small polygonal PMNT, we have 4 right angles, and according to rule 6, any polygonal that has 4 right angles must be this rectangle, if not a square. So we relate to this polygonal PMNT is a rectangle because it has 4 rectangles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle PQ, rectangle, this rectangle MQ SN, actually in this rectangle PMNT, side PT must be equal to the opposite side MN, but PT is B, therefore MN must be also equal to B. So what is the length of this line segment AM? AM equals to AN minus MN. Repeat again. AM equals to AN minus MN. So AM equals to AN, that is 8, minus MN, that is B. So in total, AM equals to 8 minus B. So here we have those two angles. They are defined as corresponding angles, and they are located between the parallel lines PQ and BC, and therefore they are equal to each other. According to the rule, the corresponding angles between parallel lines are equal to each other. So if this angle is alpha, then this angle must also equal to alpha because those two angles are equal to each other. Likewise, those two angles are both defined as corresponding angles, and they are located between the same parallel lines PQ and BC, and therefore they are equal to each other. So if this angle is B, then this angle must also equal to B because they are equal to each other. So in the next step, we proved that the big triangle ABC is similar to the small triangle PAQ. So why the big triangle ABC is similar to the small triangle APQ? First of all, those two angles are both equal to alpha, therefore they are equal to each other. In addition, those two angles are both equal to beta, therefore they are equal to each other. And finally, this is angle A, that is a common angle that belongs to both triangles. So I can write down that angle A equals to itself is a common angle that belongs to both triangles. So if I found out that all the triangles in the big triangle ABC are correspondingly equal to all the triangles in the small triangle APQ, therefore those two triangles are similar to each other according to angle similarity rule. Again, triangle ABC similar to triangle APQ according to angle similarity rule. And whenever you have two similar triangles, then the ratio between their heights must be equal to the ratio between their sides. So the ratio between their corresponding heights must be equal to the ratio between the corresponding sides. So in triangle ABC and triangle AQ, it means that side AM, the height AM in the small triangle APQ over the height AN in the big triangle ABC must be equal to side PQ over side BC. Okay? Again, AM over AN, that is the ratio between the heights of the two similar triangles, must be equal to PQ over PC, that is the ratio between the corresponding sides. Here AM is 8 minus B and AN is 8. Repeat again. AM is 8 minus B and AN is 8. Here we have PQ is A and over BC. BC is 21. So if we're going according to equation 1, we should find out that 8 minus B over 8 equals to A over 21. Here of course multiply this equation 1. If we found out that A equals to 21 over 8 times A equals to 21 over 8 times 8 minus B. This is after we cross multiply this equation, after we after we divided this equation 1 by 8, we found out that 8A over 8 is A, and we divided this side also by 8 and found out actually that A, according to equation 1, A equals to 21 over 8 times 8 minus B. Here we open the brackets on this side of this equation 2, and found out that A equals to 21 over 8 times 8 is 21, minus, here we have minus 21 over 8 times minus B, that is minus 21 B over 8. Here we multiply this equation 1 by B. If I found out that A times B equals to 21B minus 21 over 8 times B squared. So actually, this is the function area of this rectangle PQST. Because A times B is the length times the width, that is the area of this rectangle PQST. So the area equals to 21B minus 21 over 8 times B squared. So we have the area of this rectangle PQST is function of the width B. Again, in this equation 1, we have the area of this rectangle PQST is function of B. B is the independent variable, and the area A times B is the dependent variable. Repeat again that our mission is to find out the maximum area of this rectangle PQST. In order to find out the maximum area of this rectangle PQST, we have to differentiate this function area and equate its derivative to 0. And by doing this operation, we'll find out the extreme point of this function area, and then we have to verify that the extreme point that we found is indeed the maximum extreme point and not the minimum extreme point. And we find out whether if the area of if the extreme point that we found it is maximum extreme point or minimum extreme point by drawing the graph of this function area. And from the graph it will be very easy to see whether if the extreme point that we found it is minimum extreme point or maximum extreme point. So in the first step we will differentiate this function area. So here D is the evolution for derivative. So the derivative of this function area, that is 21b minus 21 over 8 times b squared, and we took the derivative of this function area according to the independent variable b, and then we equate the derivative to 0. So what is the derivative of 21b? The derivative of 21b is 21 because the derivative of b is 1, so in total 21 times 1 is 21. Repeat again, the derivative of 21b is 21. And what is the derivative of 121 over 8 times b squared? Actually we know that the derivative of b squared is 2b, and therefore this expression after we do the derivative of this expression, it will be equal to minus 21 over 8 times 2b. And again, the derivative of minus 21 over 8b squared equals to minus 21 over 8 times 2b. And it is equals to 0. Here we took 21 as a common factor out of this, we took 21 as a common factor from those two expressions. So what is left from 21 after we took away 21 as a common factor? What is left is actually 1, and what is left from 1 is 21 over 8 times 2b after we took from it 21 as a common factor. What is left is actually minus 2b over 8, and it is equal to 0. Here we divide this equation 2 by 21. And finally found out that 21 over 21 is 1, so inside of the equation we left only with 1 plus 2b over 8, and equals to 0. 0 over 21 is 0. So if we found out that 1 plus 2b over 8 equals to 0, here we added 2b over 8 to this equation, and finally found out that 1 equals to 2b over 8. Here we divided both the numerator of this expression by 2, so 2b over 2 is b, and 8 over 2 is 4. So in total, we found out that according to equation 2, 1 equals to b over 4. Here we multiply this equation 2 by 4, and finally found out that b equals to 4 units in its length. Okay? So the extreme point of this function area of this rectangle PQST is when b equals to 4. So when b equals to 4, we have extreme point, but the extreme point could be minimum extreme point or maximum extreme point. In order to verify that we found the maximum extreme point and not the minimum extreme point, we have to draw the graph of this function area. Actually, I want to draw this graph. This is the graph of the function area of the rectangle PQST. In the y-axis we have the area, and in the x-axis we have the width b. And it is very easy to see from the graph that when b equals to 4 units, b equals to 4 units, then the area is a little bit greater than 40 square units. And from the graph we can see that when b equals to 4, we have here maximum extreme point. That is to say, the function area is in its maximum value. So the only thing that is left to do is to find out what is the exact maximum area of the rectangle PQST when b equals to 4. So we have to put the value of b in the function area in order to find out what is the maximum area of rectangle PQST. Okay, so here we have actually the function area of rectangle PQST. It is 8 times b, it is equals to 21b minus 21 over 8 times b squared. Now we have to substitute b by 4 in order to find out what is the maximum area of this rectangle PQST. So we substitute b by 4. Again, we substitute b by 4 in this function area. So the maximum area equals to 21b, and b is 4, so it is 21 times 4 minus 21 over 8 times b squared. b is 4, therefore b squared is 4 squared, it is 16. So we found out that the maximum area is equals to 21 times 4, that is 84. Here we have in this expression 16 over 8 is 2, so in total this expression equals to minus 21 times 2, that is minus 42. So we found out that the maximum area of rectangle PQST equals to 84 minus 42, that is 42. Repeat again. We found out that the maximum area of this rectangle PQST that is located inside this triangle ABC is 42 square units. Repeat again, the maximum area of rectangle PQST equals to 42 square units. Now, we found out what is the length of this rectangle PQST when B equals to 4 units in its length? According to equation 1, the length A equals to 21 minus 21 over 8 times B. We just have to substitute B by 4. So A equals to 21 minus 21 over 8 times B is 4, so it is times 4. So A equals to 21, and here we have we divided both the numerator and the denominator of this expression by 4. 4 over 4 is 1, so in the numerator we left only with 1 is 21. Here in the denominator we have 8, and 8 over 4 is 2. So the length A equals to 21 minus 21 over 2. Minus 21 over 2 is minus 10.5. So in total, the length equals to 21 minus 10.5, that is 10.5. In conclusion, we found out that when the width of the rectangle PQST is 4, the width B is 4, and the length A is 10.5, then the area of this PQST or rectangle PQST is its maximum area, that is actually 42 square units. Okay, thank you very much.